Before we start talking about complex numbers, we have to do a quick review on square roots and radicals. The square root is any number r is a square root of a number s if r squared equals s. Let's take this English language expression and rewrite it into math. So we have our number r can be written with an equal sign. The square root is now a symbol of a number s. So we're using a variable, that letter, to represent a number. So if we wanted to use variables, we'd say r is the square root of s. We might write 2 is the square root of 4. The radical symbol is, of course, that square root symbol. The expression square root of s is called the radical. So the whole expression, the whole piece, square root of s, we could call the radical. And the symbol is the square root sign, is also called a radical sign. The radicand is that number s beneath the radical sign. So if you have the square root of s, s is the radicand. If you have the square root of 4, then 4 is the radicand. Now, remember, we've always dealt with the square root of real numbers so far. Sometimes in math we came to the expression where we'd have the square root of a negative number and we would just stop and say no real solutions because real numbers are all positives or negative. And we know that the square root, if r squared equals s from above, that means that r times r equals s. And if we have real numbers, r could be a positive number. So we could have a positive times a positive, and then s would also be a positive number. R could be a negative number, and then we would have a negative times a negative, in which case s would also be a negative number. But here we're saying that r squared, this I squared, equals a negative 1. Sorry, I made a mistake down here. If you have a negative times a negative, you get out a positive. If you have a positive times a positive, you get out a positive. If you multiply the same number by itself, you always get out a positive. Well, now we have this value where if you multiply it by itself, you get out a negative. There are no real numbers for which this is true. So mathematicians invented something. They invented the imaginary unit, the imaginary number. So if you have the square root of negative 1, we write it as I for imaginary. This means that if you take the square of I, if you square both sides, you get out negative 1. Because remember, if you have 2 equals the square root of 4, and you square both sides of your equation, then you have 4 equals the square root of 4 squared. The square root and the square cancel each other out because you get just 4. The radicand is all that is left over. So here, if you square your I value, if you square the square root of negative 1, you get out a negative number. Now, a complex number written in standard form is the number a plus bi, where a and b are real numbers, like 2 and 6, or negative 3 and 14.2, and the number a is called the real part of the complex number. And the number bi is called the imaginary part. So if we did an example that didn't use these variables, instead we said 4.7 minus 38i, well, 4.7 is called the real part, and negative 38i is the imaginary part. An imaginary number is any complex number where b is not 0. Because if you had b equal to 0, anything times 0 is 0. So if you had, for instance, 4.7 minus 0i, well, 0 times I is just 0, so you'd have 4.7 minus 0, and you'd be just left with 4.7. Well, that's just a real number. This is a real number. The imaginary number has to have the imaginary part to it. A pure imaginary number is simply if you take that complex number and now you take the real part, oops, sorry, down here, you take the real part of your complex number and you set it equal to 0. If you get if you eliminate the real part, you're left with just the imaginary part, so it's called a pure imaginary number. Because you take a plus b